Hello everyone, welcome to module 5 on engineering materials, and today we are going to see about abrasives. Okay, right. In your earlier class we saw about refractories, lubricants, and today, as I said, we are going to see about abrasives, and we will be seeing the hardness of an abrasive material, and there are classification of abrasives, we will see that, and we will see few properties of these abrasives, and then we will see the applications where these abrasive materials have been used. Okay, right. So, moving forward, in any industry, so which uses materials, right, or metals, it requires a smooth surface. Okay. So, the requirement of a smooth surface is always required because of three main reasons. One is it reduces the friction, thereby the heat loss and the safety of the material or the safety of the instrument will be safeguarded, and the reduction in wear, right. So, that means when the material starts working on, so there might be a chance of breaking the material pieces in very fine particles, that might lead to damage, right, and that also will be happening if the material is not smooth, and the appearance, the aesthetic look of the material will also be affected if the surface is not smooth. Okay. So, right. So, these smooth surfaces can be made by different ways. Okay. So, like we can remove the material whatever on the surface, and that we can do it by using abrasive machining. Okay. And we can flatten the surface, right. So, we can cut the irregularities on the surface, that can be done, and you can also fill the voids if there is any air gap, if there is any gaps in between. So, that can be filled with some other material like paint, finish or wax. If you fill that one, then you can get smooth surfaces. So, these are the different ways how a surface irregularity can be changed to have a smooth surface with minimum surface irregularities. Okay. So, in that point, so our topic will be about this abrasive machining or using abrasion and to make the surface smooth. Okay. Right. Right. This is what, right. So, you can see here this image. So, this image has got lot of irregularities on the surface. Okay. And if you are going to use a material, example an abrasive, this abrasive is going to remove the surface irregularity, and it is going to make the surface smoother when compared to the earlier one. Okay. So, this is how an abrasion works. It just chops off the top irregularity, it removes the top irregularities, and it makes the surface smooth. Okay. So, this is how it works, right. Okay. So, what is abrasion, right? So, we said that is an abrasive thing, right. And what is abrasion? Abrasion is nothing but, it is written here, scraping or wearing off something from the surface. Okay. Scraping or removing from the surface. Okay. So, it can be an already damaged surface, or it can be a very clean surface where if some other material falls on it, it might really chop off the some part of the layer, or it might form some irregularities on the surface. These kind of activities, or it can form a scratch on the surface, those are called as abrasion. Okay. So, whatever the things happening on the surface which will affect the material and make the surface irregular, so those are called as that process is called as abrasion. Okay. And abrasives are materials which can smoothen the surface, it can be used to smoothen the surface, it can be used to make the surface irregular also. Okay. But here for our studies we mainly focus on making the surface smooth. So, abrasives are materials which are harder in nature, okay, which is much harder, okay, which can be used to do all these processes like reduce or smoothen or clean or polish the surface of other less hard substance. Okay. So, abrasives are hard materials which are used to either reduce the surface irregularity or to make the surface smooth or to clean the dirts on the surface or to polish the surface where the material is less harder than the original abrasive. So, this is called abrasives. Abrasives are nothing but hard materials which are used to do all these works where the material is in less harder state. Okay. And this hardness, okay, this hardness is very important. If the material is not that hard, it can't give that abrasive property. So, when you are choosing an abrasive, it should be kept in mind that the abrasive should be very harder when compared to the material which is to be cleaned or smoothened or polished. Okay, right. As a general rule, okay, an abrasive material should be harder. Right. So, this is what I said, the material should be harder than the material which is damaged or which has to be polished or which has to be cleaned. Okay. So, this hardness becomes the basics for categorizing abrasives in different order. Okay. So, this hardness becomes the basis to categorize different abrasives in an order, and that order we call it as Mohs scale of hardness. Okay. So, it is a type of an arrangement, it is a type of an order where the different abrasives are ordered from lesser hardness to higher hardness. So, that scale is given by this Mohs scale. We will see about this Mohs scale in another couple of slides. Okay. So, this gives the basis. So, that means the hardness is very important for an abrasive. Okay. Depending on the hardness of the abrasive only, so it can be used efficiently. Okay, right. So, how these abrasives are going to work, right? So, we said abrasion, right, and then different scales of abrasions we saw. So, now we will see how this is going to work, right. So, during an abrasion, what it does is, the material is already a hard material and the material which has to be cleaned is a soft material. So, this hard material just penetrates the abraded material, it just makes a penetration into the lesser harder material, thereby it forms or it removes all the dust from it. Okay. So, it kind of a ploughing the lesser harder material from by the abrasive, and because of this that surface will be removed. So, first it penetrates the abraded material and then causes a tearing of the particles from the abraded surface. Okay. So, the first thing is it is going to penetrate the lesser harder material. Once it gets penetrated with further movement, so it will tear off the surface and thereby makes the surface clean or polished or make the surface smooth. Okay. This is how this abrasive works. Okay. It depends on the force how it has been pushed up. Okay. And it also depends on the hardness of the abrasive as well as the hardness or strength of the material which has to be abraded, right. So, the first it makes a penetration, and if there is any irregularity, this hard material comes in contact with it. Once more force is being given, so this will knock off the irregularity and it will make the surface clean and smooth. Okay. So, this is how this abrasive works, and there are three things which has to be considered in this mechanism. One is the hardness, the strength and the toughness, right. So, this applies for both the abrasive material as well as the surface which has to be clean. Okay. So, in terms of the abrasive material should be very hard, it should be very strong, it should have a very good strength, and it should be very tough. Okay. If all these three things are not met, and this material will be soft, and this cannot be used to remove the surface efficiently. Okay. So, if in the case of the material which has to be cleaned, it should be having a lesser hardness compared to your abrasive, lesser strength compared to your abrasive material, and lesser toughness compared to your abrasive material. So, these three parameters control the efficiency of an abrasive. If you are going to choose an abrasive, so that should be better than the material which has to be cleaned. It should be having higher hardness, it should be having higher strength, and it should also have higher toughness. Okay. So, these are the qualities which has to be looked for when you are going to choose an abrasive to clean the surface or polish a surface or remove the dirt on the surface. Okay. Right. So, you can see here. Okay. So, this is the material which has to be cleaned or which has to be removed. All the surface irregularities has been removed, and this is the abrasing material. You can see here this is much harder, okay, and this material is less harder. Because of this, the surface all these surface irregularities. When it comes in contact with the harder material, it just chips off, right, and it falls off and makes the surface clean and smooth. Okay. So, this is an circular motion where the abrasive comes in contact with the material which has to be cleaned by a force, right. So, with continuous rotation, the surface of the abrasive, the surface of the material which has to be cleaned will slowly gets chipped off from their surface irregularities, and at one point you will end up with a clean surface or a smooth surface. Okay. So, this is how this abrasive works. Right. So, abrasives can be of two types. Okay. So, it can either be bonded or coated. Okay. So, abrasives can be two types. One, it can be bonded or it can be coated, and bonded abrasives are attached to a matrix. Okay. They are attached to a matrix. That means it will be mixed with some other material which glues them. Okay. And they will be made into different shapes, either as a block or a circle or different shapes. Okay. And this as a whole can be used as an abrasive. So, these are called as bonded abrasives, right. So, bonded abrasives where a matrix is used, and that matrix will be acting as a glue, and those matrices most often it will be a clay, rubber, resin or a glass. Okay. So, these are the matrices in which these abrasive materials will be bonded very tightly, and then it will be shaped off, and that shaped off material will be used as an abrasive. That is a bonded abrasive. And the second type is coated abrasives. Okay. So, these coated abrasives comes in action where the abrasive material is in a very fine powder. Okay. So, when these abrasives are in a very fine powder, it gets difficult to put in this bonded form. Okay. So, because you will be requiring more amount of this matrices. To avoid this, what they do is these very fine abrasive materials are made into a slurry, and they will be coated over the surface of any thin material, and that thin material will be used as an abrasive material. Okay. So, it will be coated, okay, and it can be coated on over a cloth, paper, resin, rubber, polyester or even a metal as a thin surface, and that thin surface will be enough to remove the surface irregularities. One famous example is the sandpaper, okay, or emery sheet, where people use it for different purposes. So, that is a simple example of a coated abrasive, where the abrasive is in the very fine form. It will be coated over the surface of a minimum thickness, and there are different grades of abrasive material, different grades of emery sheets, where the grain size keeps on increasing or keeps on decreasing depending on the type of abrasion you need. Okay. Right. So, this is two different types of abrasives. One is bonded and the other one is coated, right. So, this is the example. Okay, you can see here. So, these are all emery sheets, right, and these are all solid bonded abrasives. These are all bonded abrasives, you can see here, right, and these are all bonded, and these are all coated over the surface, right. So, this is bonded. Okay. So, these are all coated one, so which can be used for abrasion action, right. So, hardness, as I said earlier, it is measured based on this Mohs scale, which is also called as Vickers scale. Okay. So, the hardness of the abrasive material is measured by this Mohs scale and or Vickers scale. Okay. So, this Mohs scale ranges from 1 to 10. So, the number for this Mohs scale goes from 1 to 10, and 1 is given for a low abrasive material, right, and 10 is given for a high abrasive material. Okay. So, it is given here a low abrasive material will have the least hardness, okay, and a high value or high Mohs scale will have a strong hardness. Okay. And this scale is from 1 to 10, and 1 is for talc, okay, and 10 is given for diamond, and diamond is the hardest substance. So, diamond has been given 10, and the order of increasing hardness for a commercially or very widely used abrasive materials, I have given it here. So, the least one is the talc, Next comes gypsum. So talc has been given 1, gypsum is given 2, calcite 3, fluorite 4, apatite 5th, feldspar 6, quartz, which is a pure form of silica, 7, and topaz is given as 8, and corundum is given 9, and corundum is nothing but Al2O3 alumina, and diamond, which is carbon, is given 10. So this is an ordering of the commercially used abrasive materials, starting with the least to the highest one. The least one is your talc, where the scale is given as 1, and for diamond, which is the hardest, the number is given as 10. Okay. So I will show you another list of abrasives in their different scale, right. So talc, as I said, is given 1. So there are materials which are less harder than talc, like graphite, right. So it was given as 0.5 to 1. Okay. Graphite is nothing but stacks of graphene sheets which are bonded by van der Waals forces. Okay. So they have a lesser hardness. So it has been given as 0.5 to 1, and wax was given an hardness of 0.2. Okay. So lesser than talc also there are materials where the hardness is given in this way, and the aluminium, which is the material which is very oftenly used in industries, has got a Morse scale of 2 to 2.9, close to 3. Okay. And brass 3 to 4. Okay. And glass has got a hardness of 4.5 to 6.5, it has got a wide range. Okay. And asbestos, which is used for a lot of purposes, it has been given 5. Okay. Steel, where we use it for different purposes, for building and construction and all these things, it comes from 5 to 8.5, because there are different grades of steel. So that's why this wide range has been given. And silica has been used, which has got a Mohs scale of 7, right. And quartz and topaz are 9. Okay. 9 and 8. Aluminum oxide or carborundum, I said, so that is in the 9, and diamond has been given 10. Okay. So this is an scale of Mohs or Vickers scale, where you can see the hardness of different materials. Okay. Right. So there is another classification of abrasives. Abrasives can also be classified into 2 types, right. So depending on how they exist here. So it can be either natural or artificial or synthetic. Okay. So abrasives can be 2 types. It can be either natural or artificial, right. And the very widely used natural abrasive is diamond. Okay. Even though it is costly, there are different varieties of diamonds that will be used. Okay. And the natural abrasives which are commonly used are diamond, corundum, emery, garnets, and quartz. Okay. See, these are widely used natural abrasives used for smoothing the surface or polishing any metal surfaces. Okay. Right. So there is another classification of abrasives, right. So as I said, natural and synthetic. Okay. And this natural abrasives can also be classified based on the amount of silica content. So it is non-siliceous, diamond and corundum. So diamond is carbon, corundum is Al2O3, and siliceous, where it is quartz and garnet. Garnet is a mixture of silicates, right. So both are siliceous material. So we can classify abrasives like this also. Okay. So there is another classification which we discussed already based on the hardness of the Mohs scale. So which are very hard, greater than 7, they are one group, and which are in the moderate, about 3 to 7, they are in the moderate, and the soft, which are lesser than 3, are called the soft abrasives, right. So we can classify abrasives like this also. Now we will go on to each and every few abrasives and their properties, and we will see, right. So the hardest one, the diamond, which was given the Mohs scale of 10. Okay. So it is the hardest substance, and it can cut any surfaces. Okay. And This is very common. Only diamond can scratch another diamond, so that much hard. So it can scratch other materials. Okay, so diamond is the hardest material and it can cut other surfaces, right? And they are inactive and not attacked by acids and alkali. So this is an advantage of using this diamond abrasives, because they are not attacked by acid or alkali. Okay, and diamonds, as I said, so not all the diamonds are used. Some diamonds which has got very good characteristics, they will be used as a jewelry. There are some fault diamonds which has got some imperfection in their crystal structure. Those imperfected one will be in the form of color or different shapes. Those are called as bots, right? So diamonds which have some imperfection in their structure, those are called as bots, and those bots which have a different structure, so they are less used as a jewelry. Okay, and they have been used as these cutting machines, or they are used as abrasives. Okay, and there is another one, black diamond, which is found in Brazil, called as carbonado, right? So they are also kind of a diamond, but they are of less quality, and these are the two types of diamonds which are used as abrasive materials. Okay, so they can be used to drill points, they can be used as a saw teeth to cut. Okay, and they can be used as a stones to grind. Okay, and they can be made into different grinding wheels. Okay, so you can see here, so it can be made like this, where you coat the surface with diamond, okay, low grade diamond, and then it can be used, or you can put it on the edge of a sawing machine, and then it can be used as a cutting edge or polishing material. Okay, right. So moving on to the next one, corundum. As I said, corundum is nothing but aluminum oxide, Al2O3, and it has got a Mohs scale of 9. Okay, and widely available corundum materials are gemstones, emeralds, and ruby. So these are the purest form of alumina. Okay, so you can see here, so these three are gemstones, ruby, and your emerald, right? So these are all very wide, naturally available purest form of corundum. Okay, and the impure form are the widely used material for abrasion, and they can be used for grinding glasses, gems, lens, metals, and metal cuttings, and that will be in this form, where the material will be shaped in different sizes and shapes, and this can be used for grinding or polishing. Okay, corundum, which has got a Mohs scale of 9, which is nothing but aluminum oxide, exists in 3 different purest form, but for abrasive action we use the least or the less quality corundum material, and they will be made into different shapes, and then it will be used for abrasion. Right. So next one is emery. Right, emery is a mixture of 2 different things, corundum and iron oxide. Okay, corundum is nothing but Al2O3, right, and this reacts with Fe2O3, right. So it's a mixture of these two. Okay, and you can see the proportion of all these things, right. So it has got a proportion of 55 to 75% of alumina and 20 to 40% of magnetite, so which is nothing but your iron oxide, right, and this 2 along with other percentage of 12% make this emery. Okay, emery is a mixture of 2 oxides, one is aluminum oxide and iron oxide, and it will be in the form of in the percentage of 55 to 75% alumina, 20 to 40% of magnetite. Okay, and the other percentage will be other materials make this emery. Okay, so in hardness scale it is around 8. Okay, and it is mostly used for hand polishing. It is mostly used for hand polishing, where you can control the force of abrasion or the abrasive action. Okay, so the grinding power depends on the amount of alumina present. Whenever the percentage I said, right, it varies from 55 to 75. If it has got a 75% of alumina, then the abrasive action will be more. If it is having lesser percentage, then the abrasive action will be lesser. Okay, so we can have a wide variety of different emery sheets where you can choose the alumina content depending on the abrasive action whatever we want. Okay. So, emery is a mixture of corundum and iron oxide, and the proportion varies, and in most scale it is given as 8, okay, and mostly it is used for hand polishing. Right. Moving on. So, that is the sheets. Right. So, this is emery stone, okay, and this emery stone will be made into fine powder and then it will be coated, and that is your emery sheet, and the aluminum content can also be varied in this one. So, moving forward, and the next one is garnets, okay. They are trisilicates, okay. There are trisilicates of alumina, magnesium and ferrous, okay. So, they are trisilicates of these three material. It will have alumina, it will have magnesite, magnesium, and it will have iron, okay. So, this is the molecular formula for garnet, okay. So, there will be a change in the composition. You can have magnesia also, magnesium oxide also in this one. So, this is some rough estimate of the percentage of your different components, your trisilicate in the material garnet, and these garnets are not that hard, okay. So, these garnet materials are used for polishing wood surfaces. Since these garnet materials are not that hard, they are not used to polish any metal surfaces. Instead, it can be used to polish wood surfaces. So, that is why this has been used. Here also, they will make it into a fine powder, make it a fine coating over a paper or a cloth, and then that sheet will be used, okay. So, and the hardness for this ranges from 6 to 7.5 as per Mohs scale, okay, right. And the next one is artificial abrasives, okay. Artificial abrasives, the first one is carborundum, okay. Carborundum is nothing but silicon carbide, okay, and this silicon carbide is synthesized or artificially made by reacting silica, that is sand, SiO2, in presence of carbon at a very high temperature of 1650 to 2200 degrees Celsius in an electric furnace, okay. So, if you make these conditions, when you react silica with carbon at a very high temperature, you will end up with silicon carbide with release of carbon monoxide, okay. So, this silicon carbide can be made into fine powder, and it can be made into different shapes, and then it can be used as an abrasive material. Since this is brittle, their percentage of strength will also be lesser, okay. So, that is why it will be made into either in the bonded form or in the coated form, okay. So, this is carborundum. Alright. So, the next one is alundum. Alundum is nothing but aluminum oxide, and this aluminum oxide is done by heating bauxite, ore of aluminium in presence of carbon and in presence of iron to get aluminum oxide, and this is also done at a very high temperature, where the temperature is around 4000 degrees Celsius, bit higher than silicon carbide, okay. So, when you do this, you will get aluminum, okay, alundum, so which is nothing but aluminum oxide. And the next one is boron carbide, alright. So, boron carbide B4C, okay. So, this is done by heating boron oxide in presence of carbon at a temperature of 2700 degrees Celsius, okay. So, this boron carbide is made by heating boron oxide in presence of carbon at a very high temperature of 2700 degrees Celsius, where you get this boron carbide, okay, right. So, the applications of abrasives, right, applications of abrasives falls under 4 main categories. It can be used to clean the surface, okay. So, where the surface is not smooth, where it is bit porous, you can clean the surface with this abrasives, and we can use it for shaping, okay. You can use it for shaping different materials. So, we can use this, and for sizing, right. So, make the size smaller or reduce the size, for that we can use, and for separating as in cut off or slighting operations, where you have to cut off anything. So there also these hardness or abrasives can be used. Okay, so these are the applications of abrasives, and then some of the factors which has to be considered. Okay, so depending on the abrasives are, so the difference in hardness, the first one I said. So the hardness scale, based on the hardness scale, we have to choose which abrasive we can choose. So the difference in hardness is one, and the second one is the grain size. Okay, how bigger the size is. If the bigger the size, it can be easily worn out. So the smaller the size, it can stay for a longer time, and you can use it for higher time or higher duration. And adhesion, how strong it has been adhered to the matrix or to the glue, so that it stays there for a longer time, for a different kind of force it will stay. So this adhesion also plays a major role. And the contact force, how much force you are going to give to do the abrasive action, that also a main factor. And the last one is loading. Okay, so loading is nothing but when you do an abrasive action, the surface will be worn out, and the removed surface, the removed particles might go and fill into the particle, and then it will hinder the abrasive action, right. So this also is a factor when you are doing this abrasion, right. So that we call it as loading, right. So these are the 5 characteristics which has to be looked for when we are doing abrasion. Okay, right. So that finishes our class, and if you have any doubts, you can contact me, and thank you for your patient listening. Thank you.